Okay, well, remember the days when people didn't expect to get cell phone coverage in a basement or even that well inside? Or if you were by a tree and it didn't work too well, you just kind of wandered off somewhere else to get it. A lot of them don't think that way anymore. Recently, we put in a new student health center. It had things like antibiotics down there and vaccines and other sort of drugs, and the IT department was down there, and the student health insurance office was going to be down there. So I was asked to come to the planning meeting for it, and the project manager begins to describe the need for communications down there, and silly me, I'm about to say to her, how many landline phones do you want? And before I could get the words out of my mouth, she goes, landline phones won't work. So I said, okay, how much budget do you have for this? And it's not cheap. So anyway, it was important enough they went ahead and budgeted for it. And the budget, just to give you an idea, this is just the basement. Okay, so you'll see these things aren't cheap. Was $65,000, and forget the other floors. So anyway, but fortunately the carrier, who's AT&T, they ended up stepping up and out of generosity covered it for them. So anyway, that's basically what the world we live in, and this has gotten to be a hot topic on college campuses, and if you follow a CUDA listserv, it constantly comes up as far as getting cell coverage into buildings, because essentially people want, anything, anywhere, anytime now. And they're very mobile. That's us. We've already been introduced. Okay, just an overview, a quick look at technology. Some of you are doing this already. I know UC Santa Cruz was one of the first in the state to do it, to get involved with DAS. So they could come up and just about give the presentation themselves. Just as there are 3 layers, if you remember your Cisco certification, of some of us that went through that many years ago, that you got this beat into your head. There were 3 network layers, so help me out here. There was the, oh, you've forgotten? The core, okay. And then there was the distribution layer, and then there was the access layer, okay. And that's the way it was built out. Well, the DAS network is pretty similar. Not exact, but it's pretty similar. You've got your head end, okay, where the carrier is coming onto your campus and they're connecting back to their point of presence, because it just doesn't magically fly through the air. And there's a whole lot of capacity needed if you're going to disperse this, or heaven help you get into a stadium or another large venue. They have to have a way to connect back to their network, bring that onto the campus, which can be quite a bit of equipment, and then in turn, you're going to connect it to your DAS head end. So that's how they're getting to the campus. That's your starting point to launch into the rest of the campus. Now the runs are pretty long, okay. So you're going to building, you need a distribution layer. So you have all this DAS remote equipment out there, just like you did in a data network. And you're going to connect to that from the head end to the distribution equipment by, guess what? Copper going to run that long? Nope. Fiber. So you're going to run fiber all the way out there to connect to it. And then you have within the buildings, and sometimes just like the data network, you'll have multiple switches in there, sometimes every other floor. You've got to connect to these antennas, okay? Now, and of course you have, don't forget your cabling that gets involved in this, fiber. Depending on the technology, if you're using like CommScope, they want coax to connect to the antennas, or you can look at an Ethernet-based solution. Now, in the data world, if you're running on copper, whether it's 100 meg gig, okay, you can go from your distribution switch to the access or to a computer, whatever you're getting to with copper. How far can you go? Standard. 100 meters, right, okay. So, in a DAS world, it should be the same, right? Nope. As far as the coax, you're pushing RF, they like to go 100 to 150 feet. So now you're looking at more distribution points as far as how far can you get to the antennas. Now you don't have to go desktop, so you do have that advantage. And you don't have to have an antenna in every room. But the runs are kind of short. Okay, just a quick look at indoor DAS. This is one carrier's equipment that serves 2 buildings. Those are remote radio units, or RRUs. And that's just a piece of their equipment, okay? The RRUs are by band, so you don't have one RRU that's going to do 1900 and 850 and 700 LTE. Separate RRU for each one of them, so you'll typically see like 3 in this case. That's the DAS head-end equipment serving the buildings. You can see the RRUs there to your right. This is kind of a nifty little piece of equipment. You can see them kind of stacked there. One of the issues as far as when you're looking at, and it's not so much just technology, it's 911, is the carriers will locate 911 by, and some of them do it a little bit differently, but it's basically by sector. Okay, so if I'm feeding a stadium and I got lots of capacity and I have this little building over here that's maybe a mile away or whatever it is, it makes a lot of sense if I can use that capacity maybe to feed this little guy, but it's not that easy because I'm running into 911 issues. So typically the way you have to do it is, even though that might be a little spot, you've got to dedicate RRUs for that little guy just for 911 issues. What the pilot beacon does, Verizon's one of the early ones to use it, the other carriers are looking at it, is to take that same sector and you have the ability to feed it with different 911 information, or it's feeding it. So if somebody makes a 911 call here, I know they're over here, and if they make one at the stadium, I know they're over here. That's a pretty nifty little device. And it's a lot cheaper than putting in separate equipment. The building, this is just real quick in the building, MDF, that's DAS head-end equipment connecting back to the core, and then of course to the carrier side. That's something you might see on every floor, every other floor that's going to feed the antennas. And that's just one of the indoor antennas that's serving the building, about the size of a smoke alarm. So not too big, and if you have a ceiling that you can get up underneath, you can put it underneath that one. Whoops, I got to slide over. Okay, Eric, I'll get that. And I know what I'm doing.
I'm a little shorter. So I'll give you a brief overview of what we have done at Stanford. Again, we also kind of delved into the foray of DAS. When students started showing up en masse with cell phones about 5 years ago, we started off with typical having a couple macro sites on campus, on the east side and the west side of campus. We have a couple of carriers that are on those macro sites, but not all of the carriers. We've deployed some cell on wheels. Again, we had a couple of them early on to really kind of plant it into the student residential area, because again, they were just gobbling up bandwidth left and right. We also recently put one in near the hospital. They're in the middle of putting in an in-building DAS system right now. And again, they've got doctors, people screaming, don't have coverage, life safety, things like that. So we put one in temporarily. The county hates hearing temporary. As I said, we put a couple of cows over in the student residential area, and those were there they were supposed to be there 6 months, and they were there probably close to 3 years. And so they were very hot to get them out. We actually, because it's close to the faculty area, the faculty subdivision, we had faculty screaming too. They didn't want the radiation from a cell tower right in their backyard. So we went down the path of the DAS. And after we actually went out to UC Santa Cruz and looked at their next G installation, got a lot of valuable information from them, came back, set out an RFP. We invited Crown, NextG, a couple other vendors, came back, and Crown is who we decided to go with at the time. We currently have deployed it in 2009. We have about 23 locations, they're called radio access nodes across the campus that feed pretty much everything. We also have in the stadium, Crown has a DAS system in there. We have AT&T and Verizon on it. The other carriers have not been on that as of yet. AT&T also worked with our athletics department. So one of the challenges we've had is getting all of the schools, departments to really come into a central location and really kind of manage that whole cell stuff. We have a couple of locations that were in buildings that were put in by a single carrier. They're still kind of their legacy systems. But again, it was departments going out and negotiating on their own and really not leveraging the whole campus. So we've had to really kind of rein them in. The stadiums are another item that we'll talk about in a little bit. From the carrier standpoint, it's a revenue. And that's really what they're looking at, is how can they generate revenue off of their cell business. We have a head-end room that we put on top of Beckman, which is over near the medical center on the west side of campus. And we are promptly, through the outside DAS, blowing through our space and actually adding a secondary location over on the east side of campus. They'll be tied together with fiber and expanding in there now that we're starting to delve into the in-building DAS. Again, I said most of the carriers have bought on. One gap is Sprint. We have not had Sprint buy into anything. We've had one of their cell on wheels actually leave, which has left another gap, but they still refuse to join in. And I've talked to other schools, and it seems to be a common problem. They're just not buying into things. So we'll see what happens with them. Time will tell. So essentially, the business model that we have with Crown, and it's typical for the vendors, is that basically they fund the building and they get the carriers to come back and subsidize that and pay a monthly rent. So it's essentially a no cost for us, which is very nice. And on the outside DAS, that's worked very well. We are looking at expanding. As you say, coverage is a constant issue. So we're looking at our faculty subdivision. It's right off on the edge of the campus. There's some big gaps out there, so we're in the process of working through those locations, trying to nail down where the best locations are. Challenge is always people don't want to see towers, things like that, so we have to find creative ways of getting them integrated. So these locations are out on the, trying to get on the main thoroughfare, covering some of those gaps. On the campus, there are some locations that we'll also be adding in. They just built a new concert hall over near the stadium. There's a lot of parking in the area that they just built. It's also in a eucalyptus grove, which is another challenge. Trees, actually like eucalyptus, lots of oil, don't transmit signal through very well. So we have to supplement that area. Tresser Union is also over in the center of campus where there's a lot of student activity. There's eateries, the bookstore, post office, things like that. So we're having to supplement in that area as well. And then the stadium, ironically, AT&T requested a 16-sector design for the stadium, which Crown built, and they only brought in 8 sectors. They figured, we'll see what happens. They bust all of them together into pairs and had a lot of problems with coverage, so this year they're in the process right now of adding those other 8 sectors. So it's a constant churn of trying to stay on top of bandwidth. These are basically the locations on campus. The areas that we're adding, again, that I was talking over near the stadium in this area, and then the faculty area is actually here off the map. You'll notice, though, that a lot of the concentration is over in this area, which is, guess what? This is where all of our student residences are located. So you'll see they're spread out a little bit further around the campus. But we have a huge concentration. So one of the things that we have is a lot of students live on campus. There's probably 95% of undergraduates live on campus, and over 60% of our undergrads live on campus as well. So a huge student population right here local, and all of them expecting coverage. So indoors, this is where it has gotten real challenging. The model that we use does not work indoors, flat out. It's The carriers really, they figure you've already paid outside, or they've already paid outside to get service, and they're not on the hook to provide it in every nook and cranny in every building. And so we've had a huge amount of effort that's gone in over the last year, 2 years now, trying to get the in-building buy-in. And so we've got one of our engineering buildings, it's a brand new building. T-Mobile actually came in as an anchor, so Crown went and built it. So now they're kind of on the hook to get the other carriers in to help pay for the capital costs that they put out. And we have 13 other buildings that we're looking at an in-building solution. And ironically, they're all new construction. New construction seems to be a big problem. A lot of concrete, thin concrete walls, a lot of steel, and a lot of windows which are tinted with metallic tinting. So we've essentially created buildings that are screened. And we have the same problem on the inverse with our wireless even. We got wireless inside, can't get outside. They got cell coverage outside, we can't get inside. So we spent the last couple of years working with all of the carriers. We've really narrowed down to AT&T and Verizon are the only ones who have any interest in the game. And we've come up with a model. In fact, I was talking with AT&T the other day, and they said, we haven't done this before. But what we're trying to do is get everyone involved, from our group in IT services, the schools, the carriers, even Crown, to have some skin in the game to make this thing work. And so we have a model where we essentially have the schools investing about 1/3 of the capital cost, and each of the 2 carriers investing 1/3 of the capital cost. And we're picking up the monthly recurring costs. And I've done my share of working with Crown to help get them also to put some skin in the game. So we've really brought down the price. When we first started looking at in-building, we were hitting costs of $3.50 to $4 a square foot. We're down to $1.50, plus or minus, maybe close to $1 in some places. But it has not been easy getting there. Just to give you an idea, we have a little over 600 buildings on campus. So 14 buildings is really a small piece. Not all 600 buildings will need coverage. Some of them do have coverage, depending on the construction type. But it's something that we're looking at going forward as well. So really the issues that we've been dealing with is cost, number one. It's very expensive. Timely, because the carriers really don't want to buy in. They drag their feet and drag their feet and drag their feet. So it's been about getting them to the table. We've gone through a lot of different methods. One of the other things they try to tie into it is commitments. And so, in the university, it's hard for us to say we're going to be just an AT&T shop or just a Verizon shop. We have, I've heard somebody speaking earlier, they have about 40,000 people on their campus on any given day. We're right up in those numbers too. We can't control who everybody is going to go with their carriers. Students coming from all over the place. They have whatever friends and families they have from where they came from. So trying to go with a carrier-specific system really is problematic. We can't force people to move over to a carrier. So it's about getting all of them involved. The carriers have their woes. Again, they're for-profit. That's something that we have to contend with. Trying to get into their fiscal budgets. If you're going to do this, you need to do it early. So if you're trying to get something today, you're too late. If you're looking at buildings 3-4 years down the road, now's the time to be talking about getting something in those places. Construction materials, as I mentioned before, is a huge issue. It seems that the newer the buildings, the more, because a lot of, and other places are doing this too, trying to go for LEED, trying to go for energy efficiency, all of those kind of things, they really don't lend well to permitting signals in and out. In some ways, though, that's helped us a little bit because the emergency frequencies are starting to experience the same problems that the cell carriers are. So it hasn't come code yet. I know it'll come soon, but most of the counties, at least where we are starting to require in-building systems for the emergency frequencies. Lo and behold, they use the same type of technology. It's just getting the extra frequency. So construction costs, you build those in. You have to put that portion in because the county is going to require it. hey, for a few dollars more, we can build out the cell portion of it. Add a few WAPs, add a couple of boxes. Now you start getting appetizing. I think down the road, if you're going to put in-building in, you're probably going to be paying for most of it yourself. But don't not try to get the carriers on board. The thing I learned that was most important was, when we first talked about going with a distributed antenna vendor and a neutral host, I was like, great, they'll take care of everything. I'll just sit back and tell them where we need it. Wrong. It's constant engagement, not just with the vendor, but also with every single carrier. On a daily basis, it's about letting them know what you have coming up. It's about prioritizing what is important to you. Our hospitals kind of pulled some weight this year to get their chunk of AT&T's money, for example. That kind of put our 14 buildings and the other locations on hold. They pulled the life safety card. That's something that the carriers acknowledged in the hospitals, but when it comes to the buildings, it's not their responsibility to make sure that's there. But again, also the emergency frequency stuff is really important. That's something, but again, that helps us going forward with new construction. It's still a matter of trying to figure out how to get coverage into the existing buildings. So unfortunately, there's not a whole lot of other solutions. You've heard of microcells. AT&T has them. They handle 4 calls simultaneously. You can put into 10 numbers up to 10 numbers in the unit. But again, they don't auto-register, so it's really very, very niche. We have been talking to AT&T. They have something called a Metro Cell that's in pilot right now back east with a couple places. We begged, pleaded, screamed, hollered, threatened, jumped to get on that pilot. They said no, their lawyers wouldn't let it, but they said in about 2014 it's due out. So again, thinking about the carriers, figure another 6 to 9 months on top of that. But that unit is a little bit hopeful that it can cover a larger area, so it's not deploying a whole full floor DAS. So that's one of the things we're looking at. Another thing we've looked at is leveraging our Wi-Fi. It is something I know T-Mobile kind of announced it quietly, that you could make cell calls through a local Wi-Fi. It's not advertised a lot, and they may actually have pulled it back. But because you can just imagine everybody toggling over to Wi-Fi and making calls left and right. I know our networking folks would not be happy if we crashed the network making cell phone calls all over the place. But we have talked with AT&T specifically. One of the things that we can do is push their SSID through and tunnel them out. Unfortunately, on their side, their lawyers have a problem with that because now you've got their client information, traffic, things like that you could monitor is what they're worried about. But I think in the next couple of years, just looking at what in-building DAS costs, it'll kind of push that issue to where they have to do something, and there are ways of doing it. Bottom line is there is no silver bullet for DAS. There is a tool bag that you apply in different places. So I think I have a couple pictures too, just of our head end up on Beckman. Which again, they're blowing out of real quickly. The space that is there is kind of already allocated. We have an indoor portion and an outdoor portion. Carriers, they don't matter. They have all of their equipment they have cabinets that handle both environments. We have stuff on telephone poles. We have monopoles. We have whip antennas. We have all of the standard antennas. And that's me. That was me. This is yours then. Yeah.
Okay. Let's see, I was just wanting to give a perspective from another type of campus. One of the things that, I'm aware of when I speak about with other campuses and how much DAS have been able to deploy, a lot of it is related to if they've got a stadium on the campus or not. It seems like the carriers are really keen on prioritizing those campuses, but we have been able to do some things here at UC San Diego, and we've got some plans for the future. Let's see, how cellular coverage works today is that we've always had some, well, for a long time we've had macro sites on the campus. All of the carriers have got at least one macro site on the campus. Most of them have got two. The campus is surrounded by other macro sites, and a lot of them have kind of optimized and are pushing antennas towards UCSD. That sort of been worked okay for a while, particularly for the outside coverage. But then we still had the challenge of increasing the density and the capacity as well as just the coverage. We have problems with new buildings going up. New buildings are larger, they're energy efficient, which means that the RF frequencies bounce off the windows. And so we realized we would need to try and make some changes. Since 2009, we've had a DAS system on the campus. In fact, AT&T actually came to UCSD and said, can we have a third-party provider do it for us? Initially, it was NextG Networks. NextG have since been purchased by Crown Castle, so it's a Crown Castle system. It was designed to improve capacity and coverage, particularly in the central part of the campus. And so we've got a head end which looks very much like everybody else's head ends. We've got 5 rooftop sites all around the central part of the campus. AT&T is the sole carrier, although we and I'm sure Crown Castle are very optimistic that we might be able to persuade more carriers to participate in there. AT&T and Crown Castle are presently upgrading to LTE. We have found that different carriers have different approaches. Sprint, I don't think see DAS as part of their strategic goal. T-Mobile are more interested than they used to be. Verizon spent more money more recently on putting up a macros site on the campus, but we're hopeful that they'll be sort of interested in partnering on the DAS system which Crown Castle run for us. Each carrier also seems to have different sort of funding priorities, and their interest sometimes kind of waxes and wanes with their passing years, depending on other priorities for their funding. The outside coverage on the campus is mostly fairly good, with the exception of the Scripps Institution of Oceanography, who are down the hill on the the prettiest bit of the campus, which is down near the ocean. Let's see, the indoor coverage, as I've said, we've got problems in some places, not just in basements, but in the hearts of some of our newer buildings, some of the concrete buildings. This particular building is tremendously energy efficient, and it's an example of one of the ones which is like a large Faraday cage, and we've got challenges within this building on cellular coverage, as you might find out if you wander around a little bit. Just showing where some of our antennas are. Some of them are up high. Sure you guys have probably already seen it. Some of the antennas are down relatively low. This is one just on the Price Center, which is pointing over towards the library. And some of them are in strange places. And see, what you can immediately is obvious here is the fine antenna system, which is sitting up there. And that's on the EBU 1 building, where we had bad coverage, but that particular house has got tremendous coverage. So what are we hoping for as we're going forward? We're hoping for more rooftops. The central, we're located, all of the rooftops are in the central part of the campus. We would like them extended more towards the School of Medicine, particularly down to Scripps Institute of Oceanography. And we're cautiously optimistic that the carriers are going to start seeing this as one of their priorities as well. We've been surveying some of the buildings, including this one, where we believe that we've got the biggest challenges, And so now Crown Castle have got the hard data, which they can help make their case to the carriers and saying, look how bad your coverage is here. DAS would sure be a good solution to that. Our kind of the business model for this is that is funded by the carriers. The carriers pay Crown Castle to operate the DAS system. Crown Castle give us a small part of the money, and it's not a huge money maker for us, the DAS system, not like the macro sites that we have on campus, but we see it as kind of a benefit to the campus, and we're willing to live with that. When it comes to indoor coverage, it's a lot more challenging, and as kind of Erich mentioned, the financial case kind of falls apart a little bit, particularly from the carrier's point of view. I think it's still our intention that as a public university, I think it's very unlikely that we will or should be using taxpayers' money or money gained from research to kind of subsidize anything on the in-building side of it. For particularly since the main beneficiaries will be the commercial carriers. The challenges we have for the indoor coverage is, first of all, by putting up more rooftops, we know that there's going to be sort of better angles and sort of more power being directed into the buildings. Things are going to get a bit better. And then I think what we'll be able to do is survey the buildings and then look and see how to fill in some of the gaps. Some of the gaps might be filled in with the indoor DAS, although we see DAS as something which was kind of developed as an outdoor technology with outdoor sort of products and funding models and architecture, and moving it to the indoors is what creates challenges for the financial case of it. It could also be the case that it can be viewed as kind of a part of a solution which might, which I believe is developing. There's going to be, you mentioned the kind of residential type femtocells, but I think the people are starting to develop more in the enterprise grade femtocells and picocells, which are actually kind of installed and managed by the carriers themselves, and connected back with a backhaul for IP. Could be their IP network. We'd be happy to speak with the carriers about giving them space on our IP network as well, although as you've pointed out, Erich, there's challenges with that. The Wi-Fi calling, I myself do use the T-Mobile Wi-Fi calling. I don't have a problem making phone or receiving phone calls anywhere inside any of our buildings because I just turn on the Wi-Fi and it actually works very well. I don't think there's going to be ever a huge volume of cellular calls, particularly as when you see what a small bandwidth it takes up compared with a lot of the other sort of wireless traffic. So I don't see that as a huge issue. I like the T-Mobile mobile calling and I wish more people used it. Another thing that we're testing and we would be relying on our Wi-Fi network is the PBX we have is Astra. Astra, who used to be Ericsson, have put a lot of development work and are one of the leaders in always best connected and mobility. So we're currently starting off a test into the Astra mobility client, whereby if you call your university PBX line, it'll also find and ring your cell phone, and it'll find it whether it's on a cellular frequency anywhere in the world or on a Wi-Fi network anywhere in the world. And so I think that will solve some of our problems. It'll particularly for people who are occupy the same buildings and the campus buildings all the time, they're employees here. It wouldn't be a great solution, obviously, if you've got a lot of people coming to watch football games and sporting events and cultural events on the campus. That's a different type of crowd and require a different type of solution. Also, there's lower frequencies obviously penetrate buildings better. There's been some talk about the carriers in the future starting to use some of the lower frequencies which are presently dedicated to data services for some voice services as well, and it would be interesting to see to what extent that might improve things. And really, the HetNet is just like the name given to having lots of different components and technologies all focused on the same solution, which is the better cellular coverage throughout all of the buildings. So that was kind of where we sit today at UCSD, and let's see, how are we doing for time? If you're wanting to have a discussion, do you want to go through the stadium quite quickly, or leave a bit of time for discussion?
We're fine for time. Probably some people
Okay.
are busy a little early, but we're
Okay. Well, do you want, yeah.
Okay, so the stadium takes you in a different direction, because when you go to the stadium, is the issue really coverage? You're sitting there with a full set of bars, and what happens? You can't make a call. No, you can't get a text. So it's more of a capacity issue. And you run the same thing with Wi-Fi. If you've got 200 students slamming an AP, they can overload it. So with the stadium, it's designed a bit differently. Before I get to that, it's kind of, because if you think logically, okay, at least the way I would think, on campus you can have thousands of students wandering through, they've got their cell phones, you've got visitors, you've got faculty, you've got staff, okay, and you have a stadium where most of the time it's doing what? Growing grass, right? How many games a year? 6, 7, and then a few events. So you figure, okay, the priority should be the campus, but the carriers know their business and they say no. We want the stadium done first. Okay, who am I to tell them how to spend their millions? So anyway, this was the top priority they wanted to hit, was the Coliseum, before they did anything else. So we looked for a space, and as you saw from Erich's picture, they don't need Cadillac space. So if you're thinking of selling them on data center space where you're going to charge $30 a square foot or whatever, they're not interested. They can spend their money a lot better in other places. They just need basic space. For us, the AT&T and Verizon already had cell sites in a parking structure. Parking structures are real nice because they're made to take weight, okay? And you don't have to worry about reinforcing floors or anything like that. They already had fiber to it, so they didn't have to worry about pulling fiber because, again, they use that to connect back to their network. So Verizon had enough room to cram their gear in. AT&T had to do quite a bit of an expansion, and they literally, to try and make the season game, they were working 7 days a week, 12 hours a day. They put the crew out there. This is just one example of a carrier's head-end equipment that's serving the stadium, and that's only part of it. Okay, that's not all of it. These are batteries that one carrier uses to back up their equipment. If the power goes down where your head end is, if you don't have backup, you're going to lose your cell coverage. So this is just a few of the batteries that you're seeing. They've stacked them up and pushed them on the side. That can give them a few hours of power. But these are some of the things you have to think of, is if I lose power, especially if you're in a stadium with 93,000 people, you want to make sure your DAS doesn't go down also. And they're probably going to get on their phones as soon as it happens. Either, wow, look, that whole half section went out, like the Super Bowl. Or, I'm here, or where are my kids? This is the head end that, I'll use my mouse. Oh, there it is. It's not working too well. Oh, there it is. Each one of these guys right there, they feed a sector. Okay. So it goes to the carrier equipment. Each one of these feeds a sector in the stadium, and you're dividing the sector up to handle the capacity. So each sector in the stadium is like a little cell site as far as the capacity it can handle. At the Coliseum, one carrier has 22 sectors inside the bowl plus more around it. Another one, maybe not as many subscribers, they have a dozen, but that's how you're going to carve it up to handle the capacity. And you're dealing not only with voice, you're dealing with data. Guess where we have more issues? Social media. The college students love it. People get on there. They're checking scores. They're actually saturating the data in more. The carriers have no equipment to feed the DAS at the Coliseum, which is about a mile away. So Crown pulled fiber over there. It's no problem as far as attenuation. So this is just a portion of the DAS head and equipment that's serving the Coliseum. That's another view. You can see the fiber there. And then that heads out. The main feed point is the room on the concourse level. And from the concourse level, it goes around the stadium. It can feed down to the lower tunnels. Okay, and that's just some distribution equipment as you're going around the concourse. As I mentioned, your coax can only run 100 and 150 feet. So where you have electrical rooms where you can put this type of gear in that's going to connect via fiber and then go coax to the antennas, that's what you're going to do. That's the cable tray that, again, it's on the upper concourse. These guys right here, those are DAS antennas. So when people are walking around the concourse, that's how they're getting their cell coverage. The two carriers currently are AT&T and Verizon. T-Mobile is looking to see if they can get the budget to join. That's fiber. That's coax cables that are feeding nearby cell sites. DAS antennas. And they'll also go down and feed the antennas below. We asked Crown to make them a little wider. Right now, we don't have control of the Coliseum. We're hoping soon that happens. But we're looking at having to run data into the concession stands, which on the concourse level are cash only, as well as perhaps a Wi-Fi network. So they were very good at accommodating us on that, so we could run network cable later. That's what you're seeing there in this portion. That feeds down to the lower tunnels. This feeds into a tunnel as far as the antennas, which you'll see in a bit. That's where they had to trench to get to the lower antennas. This is a void area, so the cables drop here. They come through the conduit, and they go to the tunnels towards the front. That's just a junction box where the cable comes through. Junction boxes on the lower tunnels. That's all it has is cable. There's no power there. Power's not necessary. Those are the antennas before they're covered. One points down to the lower section of the bowl, one points up. One of the difficulties of the bowl is part of it is dug into the ground. Makes it a little hard to get to if you're just trying to run conduit there. And then you nicely cover it with a stealth box, which will be painted. So you kind of hide it as well as keep hands off it. Would you believe we had a couple fans jump on top and it was blocking their view and they tried to twist the antenna a little bit? You know, and not only is that not safe, but you got to remember that it's in a very tight alley, okay? And when you move it and now it's going to shoot into this sector, guess what? Interference. So now you're going to make all those people managing. That's an antenna on the upper level. These are two antennas inside the tunnel, so if someone's on the phone and they're walking through the tunnel and going outside, they don't get dropped. I was fairly certain, and we actually, Crown had built in that the students were going to use those as piñatas, you know, and start whacking them. But as far as I know, we didn't have any bust, either that or an angry fan. And Lord knows we had enough games to make people angry. Those are, yeah. Those are antennas that point outside to the surrounding areas, the yard level, and then there's some concession stands around. Okay, items to consider. How we doing on time? Oh, jeepers. Okay. Where are you going to put the antennas in a stadium? NFL stadiums have nice overhangs, the modern ones do. You can stick all kinds of stuff there. Those of us with bowl stadiums, we don't have that luxury. How are you going to protect them, stealth them? Where's your hub site? Distribution closets for remote equipment. We've already seen that. And then battery backup. Some of the issues that you could be facing. One option is to do nothing. Good luck with that one. Because IT people think that we can fix it. Build your own desks and they'll come. I know one university that tried that. Anyway, they're not bragging about it. Even if you build it, the carriers have to invest significant time and money for their equipment and their engineering, and if it doesn't meet what they feel is adequate specs, they aren't interested. Can't really blame them. Another one is to outsource it either third party. Some carriers will offer their own. University of North Carolina did a carrier consortium with a third party to monitor it. Monitoring can be a sensitive issue. We already mentioned lead killing it as well as tall buildings. Capacity over coverage, we did that. Make sure everyone's on the same page. If they tell the carriers and desk vendors different stories, you'll get them all confused and they're spending millions. Don't confuse them. Single point of contact helps. Forming a technical infrastructure committee where you can get various people on there, like your architects, facilities, different groups that might be involved, and get them all together so you're not running to this party and that party to get it all approved. Aesthetics on a college campus are pretty important. And those are some resources. Okay, hopefully time for questions or anything.
How much runtime do you need battery backup wise to keep this thing running when your city power goes out?
So our head end room, both of them have generator backup. So as long as we've got gas, we'll keep the head end going. The RANs don't have backup. They have what Crown will do, for instance, is deploy generators to the site as needed. If Palo Alto, we had a pretty substantial power outage a couple of years ago, and what you'll notice is that even if you keep going, AT&T, for instance, had a huge problem anyways with their network. So depending on how wide scale the power outage is, it depends. But there's not really a set build for power outage.
Are there any regulatory requirements for backup?
You guys want to just use the mics because we're streaming.
Hello? Oh. Not that I am aware of. No, not at this time. Is it 4? I know on our access control we have 4 hours, but the cell side is a little bit different.
A couple questions for Stanford. I noticed on one of your slides you had a cost distribution, 1/3 paid for by the colleges, 1/3 by the carriers. I don't recall who the other third came from.
Well, there's 2 carriers, Verizon and AT&T. They each pick up a third.
So each of them picked up a
and
third.
then the school pick up a third.
Okay, and then second question, from the time you had Crown Castle install the equipment on the in-building DAS, about how long did it take you to get Verizon or AT&T to show up after that to get their stuff installed?
So Hwang Engineering Center was put in a year and a half or so ago, and AT&T and Verizon are still not there. So that's why it's also included in that package of 14 buildings. So the build cost is nominal because it was already built. So
That's what I'm afraid of.
Typically AT&T is longer.
Okay, thank you.
Have you ever run into issues with faculty who has concerns about radio, frequencies, interference with scientific instruments?
Yes, we have. Actually, it's come more from the student side. While they want the coverage, they don't want an antenna outside their room. We have a high-rise building where it's up on the roof, 8 stories, and we had a student downstairs complain. And so, number one, the DAS systems run at a lot lower power than like a macro site. And so we actually hired an independent company out of San Francisco to come down and test. And what they found was that within 1.5 feet, 2 feet of max, the power drops off to nominal. It was really kind of interesting because they went downstairs outside the student's room, and all of a sudden the level started coming up. So most of our antennas are directional, so they broadcast out, so which was up on this roof. And when they went downstairs, they actually were picking up readings from our Wi-Fi AP, which was at 2 feet away, close to what the DAS system was. So it is very low. But we have, our health and safety department had, so there's the government standards, and there's the county standards, and then there's our EH&S group. Each of them lower, just a little bit below the next ones. So ours is pretty stringent, and we've passed all of those tests. But there is always concern.
Yeah, what we have is one of the physics, I guess, faculty that were thinking about. I mean, were worried about the precision of their instrument being affected by this radio high power antenna, above this.
We have an in-building DAS in our hospital. There's MRI machines. There's radiology departments. One of our doctors in the radiology department has done a lot of studies. He's actually testified for that these really aren't a health concern or an equipment concern. So the other thing that's interesting too about when you talk about RF, because that's something that obviously is a concern of students, faculty, staff, that with the DAS system, since there's more antennas, the phones themselves are usually the biggest culprit, hanging them right up against your ear. And as you get into more antennas closer in, the phones nowadays are designed to reserve battery power as much as possible, so the quicker and sooner they can lock into a solid signal, they ramp their power back. So in that sense, it's actually a good thing.
So I had a question regarding, you mentioned coverage for life safety. So particular challenges with DAS for complying with E911 or Phase 2 wireless, or any responsibilities, whether or not you operated a call taking, 911 call taking, or the PSAP.
I feel like I'm doing all the time. Come on.
We're still getting, somewhat off the ground. Stanford and UC San Diego further down the road, but that's something to look at. Our public safety hasn't raised the issue yet, but it's fully capable of it, of being able to add those to it. But it is a good point because it does impact emergency services and safety, and you want that coverage because who knows where somebody will be when they need to be contacted.
But the carriers, when they build the system, they have to have that built in. So, if you build your own, so one of the things I told the carriers, again, we tried a lot of different avenues to get them engaged, was, well, if I build it, and you can't guarantee you come, we're going to stick a BDA and a whip up on top of the roof, and we'll steal it from the outside. And the caution is that system is not E911 compliant, so you have to make sure people realize that if you do that, that there is no E911 with it. They have no way of locating you. Similar with the Wi-Fi system. So T-Mobile, how do they know where you are? So it is something to make sure that you're aware of. Plus, you'll also get dropped calls. If you're on your Wi-Fi down the stairs and you go walk outside, it will drop your call. So.
I scribbled a couple of notes here. The first one is that what you're going to find when you look at the business page in tomorrow's newspaper is that T-Mobile and Metro PCS just merged. I think the FCC approved that today. The FCC came out with new rules for all these DAS systems on February 20th. And the systems that you gentlemen have talked about, there's no change in the rules. That the FCC took great pains not to interfere with what is a cooperative operation between the carriers and the people that work closely with them when they install these systems. But if you go to Fry's and go down the aisle, you'll find that there are a different class of vendors that sell what AT&T calls self-medication solutions to indoor coverage. And these have been in somewhat uncertain legal status, which was clarified on February 20th. And what the rules appear to be is that while homeowners can still use these things, that institutions cannot. That institutions can only use the professionally installed systems. And it really does look to me like 700 megahertz is going to be a significant bump in building penetration. It already is, but when it becomes usable for voice, and the carriers are promising that that's going to happen within 12 months.
Yeah, that's true.
Yeah, the repeater solution you mentioned, I tell people if you interfere with the carrier's network, they will find you and they can make you shut it down. And at least what I read in the release there is if it causes interference, they have the right to come knocking at the door. But there are groups that use it. You can buy them from, like, Wilson is one of the companies, and purchase them. It tends to be a one-for-one relationship, and you have like a rod or whatever. It captures the cell signal, drives it down to an antenna. One student housing put it in. It can handle up to 20 students. The 21st one comes on, they can't get on. But definitely they're out there, and you can find their websites.
The other thing to be aware of, though, with those systems is what they're doing, though, is diluting the water outside even further. So if you have spotty coverage outside already and you start sticking a bunch of whips up and bringing it indoor, you now have that many more people competing for that bandwidth. And so you may have periods of time where you feel like you're getting better signal and other periods where it feels like it's worse. So one of the things we had a hotel that was built up near the freeway, and they wanted to get the carriers involved, wanted to bring a DAS in. Nobody was interested, so they said, fine, we're going to build a professional grade system. And what I did was have them actually bring AT&T in on board, and they were actually able to get AT&T to put in an extra panel on their macro site, which was half a mile or so away, and actually point it at their antenna. The reason it worked was because the rest of the area was industrial, so during the day, everybody is there working. The macro was handling that. The hotel was empty. At night, that whole traffic shifted, so the net to the carrier was really not much. Our School of Medicine building, 4 of them had done a professional system. AT&T sniffed it out and shut them down because it was having a huge impact on our macro site.
Yeah, we've also had AT&T and Verizon discover these systems and oblige us to shut them down.
Yeah, we actually, in case you're wondering, Eddie alluded to the fact that there's poor coverage in a lot of buildings, including this one, which has the centered glass treatment. So there actually is a BDA that serves this room. So most folks get pretty good cell coverage in here. When we initially installed it, it wasn't, I guess, tuned quite right, and so we were paid a visit from Verizon. And I wasn't here then, so I don't know how this was worked out, but we're still operating it under some guise or another.
I didn't hear it.
We have one of our engineering building. The engineering students built their own, but they haven't been shut down. So.
I think we can take one last question.
It's my understanding there's basically 2 ways to do this. Either grab the signal, regenerate it, and then pump it out, or have some method of getting back to the phone company via fiber or some other means. How do you do it the other way and have a partnership to get it tunneled on fiber so you don't impact the capacity for around you? Because stealing coverage from local cell sites, at some point, that's not going to work anymore. You've already talked about you can only handle so many calls and then it starts dropping off. And having the company come out and increasing the cell tower density, that's not going to happen anytime soon. And when you're looking at several hundred, let's say you had 50 or 100 buildings on your campus that you're trying to do this for, stealing from the local cell sites isn't a way to solve the problem.
Yeah, you actually create your own problem, make it even worse. It's really about just constantly working with the carriers and pushing them to what your needs are. Like I say, we were at the point where, people are going to start building them and putting whips out, but I still want the carriers to know about it. I want to be on their doorstep, and I want to make sure that we build something that they will want to buy in, and start, allocating some dollars towards them. So it's tough because we don't have the public model where, I'm renting rooms out in the high rise and I can just build it in and, jack the rent up a little bit and get my money back over time. So it really is a constant cat and mouse game, working with the carriers, trying to push them. We'll see where we go.
And the carriers all know that the only way that they're going to be able to meet increasing bandwidth demands is by putting in smaller and smaller cells. And I think they're all committed to doing that. I think that, the DAS systems are going to proliferate not just in places like campuses, but around city centers, sort of in other areas like that. I think that any carrier that does the math has got to see that this is something that they've got to be upfront and supportive about.
And bring to the plate, when you talk with them, bring everything you have. So a lot of our new buildings, probably each of the schools have built large conference centers because that's kind of where we're going. It's all about collaboration now. It's about bringing people in to your campuses. It's about having, all of this extra traffic that maybe wasn't there before. And so, we have our housing, uses their buildings for conferences all summer long, so you've got entities coming in from all over the place. Huge amounts of traffic coming in and out of the school, and so it's an opportunity for them to catch that revenue, provided they're on board. So anything that you can bring to their plate, the better, and the more often, and again, planning out in the future, really trying to get those things out on the plate. Sit down with your carriers, and don't stop at the local salesperson. Go up the totem pole. And bring to them what you're looking for. Give them the whole package, and then try and get them to say, okay, well, maybe we'll commit a certain amount for growth over the next X years. Because, they sit, the ASG group sits on, I think it was $500 million, which sounds like a huge number. But when you think about spreading that across the whole country, it's not a lot of money. And so if you can get them committed to coming your way and again, stay on their backs and let them know how important it is. The commitment side really doesn't play a large play to them because people will bounce back and forth. And to them, they're looking at, that's why stadiums are so hot right now, is because it's a new business avenue, a new revenue stream for them. But I think that's a novelty that's going to start wearing off. Especially since they're trying to pack. I mean, you look at when they build coverage, there's the peak and the valley of coverage, and they try and find a sweet spot in between to keep everybody as happy as they can, knowing that they're not going to guarantee everybody all the time. In a stadium, when you're packing 50,000 fans into a place for a few hours a year, that novelty starts wearing off, especially if you can't meet that bandwidth commitment. It's a huge cost. And so at some point, they're going to start tapering it off. We've seen that in our stadium already. And so I think down the road, that's going to happen more. And so they're going to be looking for something new. And if you're banging on their door now with what those other opportunities are, that's a place to go.
Sorry, we're going to have to wind things up. First, let's start by thanking our presenters.